Hello. Okay, so today we'll be learning module 8, which is the last module. So the first lesson will be about data visualization. What do we mean by data visualization? Data visualization basically means that you're trying to show data in a way that will be easily understandable by individuals who are within your stakeholder groups. So for instance, you can have a graph, let's say a table, you can have a bar graph or a line graph, all those types of data visualizations. So at the point at which some steps in the data analysis process have been completed, the newly analyzed data may be difficult to understand. So this is basically what happens when you're analyzing the data. You have various data from different questionnaires or other data collection tools. So you're trying to compress it into a way that will be easily understandable by everyone who is involved. So the data may be extensive and complex. It may be residing in collection of spreadsheets and other documents. So it might be decentralized or centralized. So the question is always, how can you make sense of it? So this is where data visualization comes in. So recall from the previous models that you have analysis, visualization, and interpretation process. So basically, after you analyze, that's when you visualize, and then you interpret the data. You'll be able to see whether they are upward trends or downward trends, or they're constant and changing trends in the data. So analysis of new data leads to the discovery of relationships and patterns in the data. Interpretation of results involves a reflection on patterns in the data set. So based on those reflections, you can infer new information. So interpretation is there to help you to come up with inferential conclusions. It was able to come up with change variations from the mean and other types of statistics. So data visualization facilitates both analysis and interpretation. So which means analysis is the middle point, or it's what actually brings together the two, the three aspects of data data processing. So when you're using data visualization, you can identify patterns in the data set. You can make technical statistical analysis understandable to people with technical knowledge. So like we said, when it comes to stakeholders, for instance, you have, for instance, the community, you have the wider audiences, you have government institutions, you have partner organizations. These individuals, they have different technical knowledge. So when you're dealing with data with them and then you're trying to show them the data, it's always better to not have the same interpretation given to them. So that's why you have data visualization. And then always understand that you have to follow steps to create effective data visualization, especially if you tend to use them in communications to stakeholders, because always make sure that, like in all aspects concerning data, you should always tailor the data to, or the data visualizations or interpretations to the audience that is being given the data. Some audiences are more technical, or they have high expertise. You are going to be able to use technical jargon, or some are not. So you should be able to condense the information. So the first step is always identify the audience. So before designing a data visualization, identify the key audiences you want to reach. So you can craft the visualization to that audience. So refer to your communications plan guidance if you are unclear on what is how to define the audience, but always make sure that you define the audience so that the individuals that you are trying to show the data to should be able to understand what is going on. So you also have to define the data visualization content. So, or what content are you able to give these people? So check on communication plan to determine the need to know content. So for instance, in the project, you had particular indicators, you had particular targets. These are the types of information that you're looking for when you're visualizing the data as well. So always make sure that when you're visualizing the data, the content that you were able to come up with, you can be able to showcase it, depending on the priorities or the strategic objectives that your project had. So you use this to determine a visual picture that will be most used based on the information needs of the audience, as well as the data that's available to you. Now, the third step is always to design and test your visualization. So you have to keep it simple. So you have to test it. So with the specific content that was identified for each audience identified, you may need to design different visuals or dashboards. So once you have it, you test it with a few individuals within your team to see whether they're going to be able to come up with recommendations on how you have used the data. So the first type of data visualization is a bar chart. Now, in this one shows multiple subgroups in point in time, and it is only used when presenting various responses from only a few subgroups or points in time. So you don't need to crowd this. It doesn't have doesn't need to have too many as in data points or points of focus, but it only has to have at least a few subgroups, and it has to be at least equal to 100%. So this is how a bar chart looks like. Then you have a stack column chart. So a stack column chart shows the variation in multiple variables or options across different subgroups on different questions or different points in time. So it is useful when comparing parts of the whole across different subgroups. This chart is not appropriate when total is not equal 100% or when only presenting one subgroup or one point in time. This is how it looks like. So it's almost like a bar chart, but then instead it's categorizing each bar by percentages, changes, and whatnot. So this is how it looks like. And now you have a pie chart. A pie chart is basically a circle, and then you're trying to segment it so that you can be able to see what percentage of a phenomenon a certain variable is occupying. The pie chart shows the composition of the data set when component parts add up to 100%. It is useful in demonstrating the different subgroups or demographics represented within a data set. This chart, however, is not appropriate with more than 5 data points presented. Total does not equal to 100%. So this is how it looks like. So it shouldn't be more than five data points. So here you have 1, 2, 3, 4 data points. And then you have a scatter chart. Scatter chart shows the relationship between two continuous variables. For example, quantities or rating scale or distribution within a data set. So a scatter plot is basically two variables or quantities, and they usually applied across time. So it is useful when looking for patterns or outliers and for correlation within large data sets. So it's very useful when you're looking at patterns. So for instance, here you see that it's almost a W pattern, and then you have one outlier right here. So you can be able to see across a period of time how that is correlated or is scattered along that period. So then you have a line chart. So a line chart shows the trends across different points in time. It is useful in tracking change over many points in time, and it is not appropriate for showing cumulative data or when comparing more than different trends. The line chart is basically also across points in time, and usually these points in time are usually connected. However, it's not appropriate for cumulative data. So you can be able to, it is very comparative. So you can compare three different phenomena or subcategories of a variable. So as you can see, yeah, you have the gray line, the pink line, the black line. And then you have a line histogram. So a line histogram shows the distribution within a range of numeric data. It is useful when looking for the range to accompany an average value. This chart is not appropriate when presenting categorical data. There that can be divided into actually exclusive groups, multiple responses, or when tracking changes over time. And so an histogram is also used for normal distribution. And then you have a heat map. So a heat map shows the distribution of results across the geographic area. The greater distribution is represented by greater water current density, in this case, purple. It is used when covering an entire region or district. So this one is very useful for maps. So for those that are taking the GIS course, that means you can be able to understand how this is done. So you have a data dashboard. So a data dashboard visually displays a collection of data points to monitor the status of a project. A dashboard can include multiple visualization tools as its subcomponents. This is how a data dashboard looks like. So how do you build your visualizations? So some simple charts and graphs can be created in Microsoft Excel or other widely available easy-to-use tools. So for those that want to find out more how these things are done, you can take the Microsoft Excel course so they can be able to teach you how to do this. So for more complex visualizations, you may need the assistance of a team member or other expert who is skilled in digital software and data visualization. The other thing is I have to check your knowledge. So which of the following apply to the process of creating data visualizations? Less is more with data visualization. So crowded visuals are very less effective. You have visualization should be designed with the target stakeholders in mind. Different people have different learning styles that should be considered in designing visuals. It is helpful to collaborate on visuals within a team, members skilled in digital software and visualization. Testing visuals with stakeholders can help make sure the visual is understood. And then the last option is all the above. So which one applies to the process of building data visualizations? And then we have the second question, which type of visualization is best when you are showing changes over time? Pie chart, line chart, scatter chart, bar chart. Yeah, so which one is the best when you showing changes over time? And then which of the following best describe the purposes of a data dashboard? A visual display of a collection of key data points used to monitor the status of a project. A visual showing the distribution of results across the geographic area with greater distributions represented by greater water color intensity. A visual showing the position of a data set when component parts add up to 100%. A visual showing multiple responses across different groups or points in time. So the other question that we have to ask ourselves is, what is data interpretation? What do we mean when you say we're interpreting data, right? So once you've collected, analyzed, and visualized your data, you must interpret the data. That is, you and your MU team and other important stakeholders need to make sense of the data. So data interpretation results in the explanation you will convey when you share the results with others and when you make project decisions. Including the views of different stakeholders can also help strengthen the interpretation. So interpretation is based on the ceteris paribus assumption, that is to say all things are constant. So you're only looking within a certain modular interpretation. So you have to say on average, let's say for instance, let's say if you have to say standard deviation is this on average, because it doesn't mean that for each particular subgroup or population, statistics will actually equal the sample statistics. They always be different. So you're assuming that this is what is happening on average. So that's why you use an average or use other terms as well, just to make sure that you understand or you're trying to convey the true meaning of that data. For example, with repeated sampling, it seems as if on average, the mean is is this. That's what that's how we interpret the data, so that you are able to convey the truth of the statistics and not to mislead the public with the type of data that you have. So when do you do it? Meal planning documents provide guidance about when to interpret data. So interpretation occurs after analysis and visualization, although the process is often iterative, right? So usually it happens at the same time or back and forth. So after analysis and visualization, but sometimes even as you're doing analysis, you can be interpreting the data. So round of interpretation can lead to the need for more data collection. So once you've interpreted the data, you can say, okay, I think we can collect more data, which should lead to further analysis. So we should lead to interpretation and so on. So note that it is a good idea to plan to stop to do some basic interpretation once you've prepared the statistics for data. So once you've created the statistics, you create the tables, then you create the interpretations, and that interpretation can actually lead to you to understand what else you need to do in terms of data that you have. So this makes the analysis process much richer and it aids in learning. So as you can see, you have analysis, interpretation, visualization, and then documentation. It's iterative, so which means each stage of analysis you document, each step of interpretation you document, evaluation you also document, but also as you analyze, you always have an idea of how you interpret the data, how you visualize the data. So how do you do it? There is no prescribed process for interpreting data, but there are self-recommended practices for improving the process. Recommendations include create visualizations of results to help you understand and interpret the data. So you help with the visualizations, not to make it more complex, but to make sure that people understand what you're doing. So you triangulate the data representing both quantitative and qualitative results together so that you can compare the results. So triangulating your data means that you're looking at 3 points, right? You're looking at quantitative aspect, you're looking at qualitative aspects, and then you're looking at the interpretation aspect. And then you're combining these two to create a third point, and that's how you create a triangle or triangulate the data. So convene a stakeholder meeting to interpret the data from multiple perspectives. So that's another aspect of how you do it. The other stakeholders and see how they interpret the data, and then you combine the perspectives that you have. And then you have to plan an adequate amount of time to analyze and interpret the data. So these processes take time, so it's important that they are part of the overall project implementation plan. So they take time, it takes time for you to analyze and interpret data. So make sure that you understand that this process takes time. So you also need to plan an adequate amount of time to analyze and interpret the data. And make sure roles and responsibility around interpretation are clear. Usually, the MEO team does the initial analysis while project staff organize and facilitate interpretation events. So what makes it good? As your team and stakeholders undertake data interpretation, consider your interpretations and subsequent results and recommendations to the same lessons used to view data quality. As you say, what makes data good is its validity, its reliability, and its integrity. So validity would mean does it reflect what is really on the ground? Reliability. Did you collect it using the right amount of tools? Integrity. Did you use all the rules that there are confidentiality and other things like that? So ethics, right? So interpretation will be considered valid if you clearly demonstrate that it's based on the data that supports it. And your interpretation will be considered more reliable if you can demonstrate the consistency of data analysis methods and use or their use across multiple data sets. And the evaluation will be considered to be integral or have more integrity if you can demonstrate that it's based on data collection and analysis processes that are relatively free of error and bias. So let's ask a few questions. When is the best time for teams to interpret data? Before data is analyzed and visualized, after analysis but before visualization, on at the end of the project, usually after analysis and visualization, through the process, the other process can be iterative, leading to the informal analysis and more visualization. So which one is the best time for teams to interpret the data? So which of the following is the characteristics of data interpretation and subsequent recommendations that has integrity? So it is based on data that directly supports it. It is based on data analysis methods that are consistent. It is based on data collection and analysis processes that are related to free of error and bias. It's based on incorrect analysis. So which one is the best answer for this? So I think for now, we may stop here.